So as you look at your papers, you can see what the correct answers are here. This is the one people get wrong most often because this is not a metal hydride. And fluorine, the fluorine has to be assigned first to find out that oxygen is 0. Now, another way that we can recognize redox reactions other than by recognizing the transfer of electrons is that we can recognize them because they show a change in oxidation number. Oxidation is an increase in oxidation number and reduction is a decrease. So we're going to look at some reactions below and find out what is oxidized and what is reduced. And whatever is oxidized, we call it the reducing agent. It's a reducing agent because it allows something else to get reduced, so it gets oxidized in the process. And whatever is reduced is the oxidizing agent. It allows something else to get oxidized. So if you think of going to Hollywood to become a star, while you're waiting tables in Hollywood, you hire an agent and they're going to make you a star. The agent doesn't become the star. So the oxidizing agent doesn't get oxidized. It gets reduced. Okay? Redox is electron transfer, so you always have to have one thing getting oxidized and one thing getting reduced. It can't just run down the street to Meijer and grab some electrons and then reduce itself. Something else has to be oxidized in the process. So let's look at these examples. Here we have a net ionic equation. This is the real chemistry going on in a redox situation. So I have iron 2 plus ions. Because it's a loose ion, it has a +2 oxidation number. It's an iron ion in its ionized state. Permanganate, we got to figure this one out. So we start with a -2 for oxygen. 4 times the -2 is -8. This is going to add up to -1 because that's the charge on the permanganate ion. So manganese has to be a +7. +7 divided by 1 manganese gives me a +7 up here. Hydrogen ions, +1. Iron 3 plus, +3. Manganese 2 plus, +2. Water, hydrogen is a +1. 2 times a +1 is a +2. Has to add to 0. -2 divided by 1 is -2. So we assign oxidation numbers to everything in the equation. Now when we look at this, we're looking for what changed. So we look at iron, manganese, hydrogen, and oxygen. On the left-hand side, iron has an oxidation number of +2. On the right-hand side, it's +3. Manganese is +7. On the right-hand side, it's +2. Hydrogen is +1 on both sides, and oxygen is -2 on both sides. So now we look at all of this and say to ourselves, well, what changed? Well, iron changed. Iron went from a 2 to a 3. It had an increase in the oxidation number, so iron was oxidized. It was the reducing agent. So on a test, I might give you some chemical equation and say, what is oxidized, what is reduced, or what is the oxidizing agent, or what's the reducing agent. Those are the kinds of things you might see. Manganese goes from a +7 to a +2. So it had a decrease in oxidation number. So it is reduced. So it is the oxidizing agent. Hydrogen and oxygen did not change, so they did not participate in redox. Okay, let's look at the next one. Where? Here? Reducing agent, oxidizing agent. Rob? Correct. The coefficients in the balanced equation have nothing to do with this. we look at the oxidation number, and the subscripts in a formula come into play, but the 5, the 8, they have nothing to do with this. Okay, that's a good question. All right, let's look at the next one. Hydrogen plus copper 2 oxide yields copper solid plus water gas. So, hydrogen, this is hydrogen gas in its natural state, its oxidation number is 0. This is an ionic compound, so plus 2 for copper, minus 2 for oxide. Copper solid, element in its natural state. Water, plus 1 for hydrogen, minus 2 for oxygen. They add up to 0. So now if we look at this, we have hydrogen, copper, and oxygen. The hydrogen goes from 0 up to a plus 1. Copper goes from a plus 2 to 0, and oxygen is a minus 2, stays as a minus 2. It's really just hydrogen atoms we're talking about, not the gas. So hydrogen did what, class? It was oxidized. It had an increase in oxidation number. It was oxidized. And copper, decrease in oxidation number. It was reduced. And oxygen did not participate. Okay. You can. Okay, in these two examples, we had one thing get oxidized and one thing get reduced. It is possible to have more than one thing getting oxidized or reduced, and it's possible sometimes that the same element goes both ways. You can have the same element getting oxidized and getting reduced in the same chemistry. Okay, good questions. All right, go ahead and work out the ones on the next page. Let's just do these at your seats in the interest of time.